Section 6.2 Interactive Assignment Objective 4. According to a report, 64.8% of murders are committed with a firearm. In Part A, if 200 murders are randomly selected, how many would we expect to be committed with a firearm? In Part B, would it be unusual to observe 148 murders by firearm in a random sample of 200 murders, and why? Okay, so first thing is first, we're going to answer the first question. We want to be able to find out, it says, what would we expect to be committed with a firearm? So note that the mean of a random variable can be interpreted as the expected number of successes in n trials of an experiment. So what we want to do is we want to find the mean. In order to find the mean, we need to first find out what does n equal and what does p equal. Well, n is given, which is 200 murders, so n is equal to 200. We know that the probability is 64.8%. Converting that to a decimal is 0.648. And now we're going to use the formula to find the mean. Well, to find the expected mean, it's going to equal n times p. So therefore, we're going to take the value of 200, multiply it by 0.648 to give us 129.6. So we would expect 129.6 to be committed with a firearm. So going back to our result, there is our answer. So again, 129.6. Okay, now the next question says, would it be unusual to observe 148 murders by firearm in a random sample of 200 murders, and why? Okay, well, first and foremost, before we move any further, step one, note that as the number of trials n in a binomial experiment increases, the probability distribution of the random variable x becomes bell-shaped. So as a rule of thumb, we need to check that when you take n times p times 1 minus p, it must be greater than or equal to 10. Now, the probability distribution will be approximately bell-shaped, so in this case, we're going to take the value of n, which again is 200, times p, which is 0.648, times 1 minus 0.648. Once we find that result, we need to check to see if it's greater than or equal to 10. So when we multiply that all together, we get 45.6192, which it is greater than or equal to 10, and therefore the probability distribution is approximately bell-shaped. Now step two, since the probability distribution is bell-shaped, the empirical rule can be used to identify unusual observations. So recall that the empirical rule states that in a bell-shaped distribution, about 95% of all observations lie within 2 standard deviations of the mean. That is, about 95% of the observations lie between the mean minus 2 times the standard deviation and the mean plus 2 times the standard deviation. So now that we've already found the mean, now we need to find the standard deviation. So we're going to calculate the standard deviation using the following formula. It's equal to the square root of n times p times 1 minus p. So again, using the values of n and p, we're going to take the square root of 200 times 0.648 times 1 minus 0.648. When we multiply that together, we get 45.6192, and now we're going to take the square root of that result. We take the square root of that result, we get 6.7541987, and then we're going to round it to 1 decimal place, and so therefore the standard deviation is going to equal 6.8. Now in step number 3, to determine if it would be unusual to observe murders by firearm in a random sample of murders, we're going to calculate those two values, knowing that the mean that we calculated is 129.6 and the standard deviation is 6.8. So the first thing we're going to do is find the mean minus 2 times the standard deviation. So we have 129.6 minus 2 times the standard deviation is 6.8. That gives us 129.6 minus 13.6, which gives us a value of 116.0. And then we also are going to find, when we take the mean and then add 2 times the standard deviation, so we have 129.6 plus 2 times 6.8. When we add those together, we get the following, 143.2. So what that means is, therefore, any value that is less than 116.0 or greater than 143.2 is unusual. And our question was 148 unusual? Now, so 148 would be unusual since it is greater than 143.2. And so therefore, we would answer the following question. We would say yes, because 148 is greater than the mean plus 2 times the standard deviation.